we are going to do a label encoding. All right, so label encoder from this package called sklearn preprocessing. So I've got it, and I'm going to load this data set. All right, so this is the data set that we have, and this is what server is using. So we have the CGPA, and like I said, this is a generated data set. It has nothing to do with any institutions anywhere in the globe. So we are going to talk about a candidate in an MBA program getting placed on day 0 or not. So we have the different columns. We have the 5 predictor columns and the 6th column, which is the target variable, whether it got placed or not placed. All right. The important thing to note here is that all of these are integers, fine, or floats. They are numbers. Day 0, placed or not placed, is a string. It's an object, right? So for a logistic regression, this should be converted to ones and zeros. The process of doing that is called encoding, and there are actually 2 ways of encoding. We'll be looking at something called label encoding. So what do we do in label encoding? So I'm going to label encode. So that is what I'm going to do. And what I'm going to do is I am going to create this variable called encoder. And then I'm going to take the day 0 placed column from my data and do an le.fit transform. Right. So I'm going to take my data frame, take this column and label encode it. So what do we mean by label encoding? In the original data frame, which was this, is now converted to a data frame where the data 0 placed column is replaced with ones and zeros. Wherever I have placed, I'm going to be ones. Wherever I have not placed, it is going to be zeros. So that is how label encoding works. And this is what we are going to use. This is going to be our target variable. And even in your tutorials, we gave you a data set that was encoded. So we did all the encoding and we gave you this. This is just a demo of how to do it in Python. All right. This, you should note that in our course, we are not focused on Python coding. We are more focused on just implementing a model in a Python environment. So it is just going to be a guide. Python is just going to be the tool in which you can do stuff. That is the entire aim to show you, right? These coding, what these packages do, how are they coded, all those backend stuff, you can learn in, let's say, Python programming fundamentals, or you can learn it during your MLF, so on and so forth, the other courses. This is not a place where we will dive deep into how these codes are prepared or what do you use in what scenario, so on and so forth. Just an overview of how to do stuff for whatever model we are developing. So that is how it's going to work. Okay. And now if you see the types, it's all going to be floats and ints. So it's going to be numbers. Any questions so far? Is everyone with me? Yes, no?
So in this case, we had 2 choices. Either it's placed or not placed. So 1 and 0. Can it be more than 2?
It can. It can.
And if suppose there is a very large data set, so can we somehow get a key for what number, what encoded, can we get an encoder to decoder key?
Decode a key? What do you mean by a
Like
key?
suppose in this 1 means placed and 0 means not placed.
Okay.
So if there is a large amount of data, so how will we know which Number stands for which?
You usually take the unique values and compare it with your data set and find out. That is one way. Whenever you have more than two classes, let's say 1, 0, let's say you have 3 or 4, you go in something called one-hot encoding, where you will have different, for example, the data set that we used during our tutorials, where we said new car, used car, or there was another variable, right, R. So that was a combination, right, 1, 0, 0, 0, 1, 0, or 0, 0, 1. So there is basically 3 levels in a car. It will be used, new, or R. I forgot what was R. Swami, what was the other one? Used car, new car, and
repeat buyer.
Repeat buyer. So you have 3 classifications over there. So used car, new car, repeat buyer. You could have gone for 1, 2, and 3, but instead of that, we went for 1, 0, 0, 0, 1, 0, and 0, 0, 1. So that combination will tell you what type of buyer he is. So more than 2, it's usually going to be one-hot encoding. For 2, it's going to be label encoding. Okay.
One more, adding to Malolan. So you can explicitly define what is 0, what is 1. So that is also possible. If there are more than 2 classes, so this is generally called a binary classification problem because there are only 2 classes. So in case you're having multiple classes, you can explicitly define what is what. You can give 0 as placed, 1 as not placed, something else, 2 as
based on your problem, you can change. Correct.
Yes, yes, you can do that explicitly. Thanks, Malolan. Please continue.
Yeah, no problem. Yeah, thank you, Swami. Did that answer your question? Whoever asked me?
Yes, sir.
Okay. Right. So now we have a data set that we can use our logic model where we can fit the logistic regression model. So the next step would be fitting a model, right? That means right, we are fitting here. Logistic regression model. So what I'm going to do is I'm going to okay, before I fit a model, what should I do? What did we do in the tutorial before we fitted the model? There was one step that we did. Anyone?
Malolan, is this a test?
No, it's not. I'm just asking them to keep it a bit interactive. Nothing else. Okay. So before we fit the logistic model, we have to first define what are our x's and what is our y for the model to understand. We have to feed it like that, right? So in our case, the features, right? Features. The features from our data are basically going to be the first 4 columns, column 1, 2, 3, 4. So for that, we will be doing 4. Yeah. I think I'm back. Data. Oh, sorry, data underscore. Just do one check. Correct. So these are your features. The first 4 columns are your features. So we extract it using this line. So I just wanted to check whether 0 underscore 4 takes it to place on place here. So we have the MBA CGPA, experience, UG CGPA, and extracurricular activities. The first 4 columns and all of its rows, the 26 rows, has our features data set. The next one is going to be our target, right? So that is going to be our target. right? So we have got our features extracted and we have got our data extracted. Once we have done this, we can then go ahead and fit our logistic model. So let me just define this as logreg.
By the time Malolan completes the writing part, let me also tell you something else. So if you remember in the tutorial, we were actually splitting the data into test and train. So that's why I prompted, is this a test sometime before? So I thought Malolan is asking whether we are splitting the data as test and train.
Good one. I itself didn't catch that, Swami.
Okay, so that means it's a very bad clue. All right. So coming here, so we only have 26 points here. So therefore, we are not getting into the business of splitting this data into test and train. We are actually going to fit the model and predict on the train itself. Whatever we are training, we are going to predict on the train itself.
Yeah, correct. Good point. So I completely missed that. Sorry to disappoint you, Swami. Yeah. So we do not have a test data set and train data set, like you said. We should explain that. Here we are having only one data set. We are going to use that to build a model. And in that model, whatever we have built, we are going to check how accurate it is on the same data set that we are doing. Yeah, good point, Swami.
Sir?
Yes, go ahead.
The tutorial you're talking about, is it, it is from which week?
Week 7.
Okay, the last video of week 7 is interpretation of coefficients. There are no tutorials that I can see.
Really, we have given it. Swami, can you just check on that?
Sure.
Live. I didn't know. We have already given it and given the green signal. Okay. So that's a very important tutorial for you guys. Then I have to repeat the entire exercise a bit more slower. Yeah, in supplementary content is there? In supplementary content is there. Last question. It's not there. All right, Swami, just check up with the team now.
Yes, I'll do it right away.
Okay, I will fit the model in the meantime. Okay, this we do not know. All right. Yeah, you guys have understood till this point, or should I repeat?
Sir, till this point, I'm fine, but
Okay. Anyone else having any other concerns? No concerns? Okay, then we'll go on from this point. I'll go a bit more slower so that it becomes a live tutorial in a sense. Okay. Right. Thank you, Venu, for bringing it up. We didn't know that. Okay. So logreg model is going to be the variable which is going to carry the logistic regression model. So it's given as logreg underscore model is equal to logistic regression. It's a blank model. Okay. And now this blank model is going to be fit with the features and the target. So data underscore features, and it's going to take data underscore target, right? So let me do one thing. Let me run this piece. So the logistic model is now ready. We have given it the input, which is these columns. All right. And we have given it the target, which is this. And based on these two, it has fit a logistic regression model that is ready for use. Okay. Right. So once you fit a model, you have to check its performance, right? So what are the performances that were taught in the course till now? 7 video in week 7 videos. What were the performance measures which the professor had said?
accuracy, precision, and recall, sir.
Accuracy, precision, recall. All right. So what is accuracy?
It is the total predictions the model gets it right.
Okay. What is precision?
It is total number of actual predictions to the predicted values.
Total number of actual predictions to the predicted values. We are predicting both zeros and ones. So which is it?
The ones, sir.
Okay, I'm asking this for a specific reason. Fine. What is recall?
So recall is the opposite of precision. So
Precision. Okay.
it
Okay.
is the ratio of predicted values to that of actual values
Okay.
of
And
ones.
is it for zeros or ones?
It is for ones.
All right. Fantastic. So keep this answer in mind. Everyone keep this answer in mind. All right. And in the Excel, sir did these calculations manually. In Python, we can do all of these calculations in an automated way. All right. So once the tutorial is out, in the tutorial, we have actually deep dive into this. We have shown you how it's done in Excel, what are true positives, true negatives, false positives, false negatives, how they are calculated, what they affect, and so on and so forth. So I won't go into those details here. You are always welcome to ask those in our discourse forum, and we will be happy to answer once the tutorial is out. Right now, I will just touch upon these concepts. Okay. So to check the model's accuracy and models, let's say precision and recall, we have all the information. Just for the sake of completeness, I will get the predicted values. In fact, we do not have all the values. We only have we have only fit the model. We need to make the predictions from it. So to get that performance measures, we have to first make predictions for some inputs. So that is what I'm going to do now. So ypred is going to be equal to the log reg model, which we did, and it's going to predict. And it's going to predict for this data set called data underscore features. All right. So this is what we are going to do, and we are going to predict the values. What's happening? Okay. So now we have fit a model and we have predicted. So what does these predictions look like? So that. See, so it's an array of values. So there will be 25 values, 27 values, 1 0 1 1 1 0 0 1 0 0, so on and so forth. So these are going to be your predictions for your respective input features. All right. And we can also get the probability that was taken for making these predictions, right? So we can also get that. So this was predicted as a 1 because the probability was 0.85. This was predicted as a 1 because the probability was 0.76. This was predicted as 0 because it was 0.05. Yeah, 0.06. It should not be 0.06. 0.76. Yeah, it's 0.5, correct. Yeah, 0.05. So it's 0.05, so it is predicted as a 0. 0.3, so it's predicted as a 0. 0.7, so it's predicted as a 1. Since the threshold for the model by default is 0.5. It is possible to change the threshold. You can go into sklearn, it's sklearn, linear models, regression, logistic regression. There are several parameters that you can change. We will not dive into those for our level, but it is possible to change your threshold, right? So that can be done. So till this point, any questions, any doubts?
Sir,
Yes. Yes.
Quick question, sir, here. So in Excel, how we selected the cutoff is based on the three metrics, right? Accuracy, precision, and recall.
Okay.
And based on the fact that higher the better, we have chosen 0.4. So here, instead of 0.5, we have chosen 0.4 because
0.4.
accuracy, precision, and recall were higher.
Okay.
So how do we choose that in this Python, sir?
In Python, where you can change the value. Like I said, you can go to this. You can actually, you will have to have one parameter called this thing level, by which you can change. But just keep this question in mind. I will come to it towards the end, all right? Because there will be a difference in our answer and whatever answer sir has got in that tool. So I will answer it at that point in time. But it is possible, like I said, we will not dive into that because you have to go into, let me just show you. Yes, Scalar, model, logistic regression. So if you go into its documentation, so this is SK11's documentation. It actually takes so many parameters, all right? So right from penalty to all of these. So go read this in more depth. So here, one of the parameters will be your target, and that target can be given to whatever you want, and it will build the model appropriately. Okay. And so, like I said, I'm not dive more into this, but it is possible to change that target level, and you can play around and get the confusion matrix and do the same analysis that Sir did to find which level is good for you. All right.
Sure, sir. I'll do that. Thanks.
Right. Okay. So any other questions? Recall curves. What do you mean by that? I'm not able to understand the chat message. They will Gaia. They will guide.
Yes, sir, we have something as a precision recall curve that actually maps the precision and recall for every threshold value. That is something we practiced in MLP.
MLP is it?
For logistic regression.
Okay. For
So
different,
that is
different
precision
precisions and recalls for different values of your threshold.
Yes,
right.
sir.
You can use that. You can use that. You can use that curve, and wherever it's maximum for both, you will take. You can do that. Precision recall curve can be used. Okay. Right. So now comes the interesting part. How do you compute those values of accuracy, recall, and precision here for a logistic model? All right. So yeah, they will just a follow-up question. So you have already learned logistic regression in this thing, is it? Some ML course?
Yes, sir.
Okay, so it's already covered. Fine. Okay, well and good. Right. So what I'm going to do is, next I'm going to create something called the confusion matrix. So what is a confusion matrix? Those who have already studied ML, can you tell me?
It quantifies the true positives and all those four metrics, true positive, false positive, true negatives, and false negative in a systematic visualization.
Okay, so I'm calling it a confusion matrix. So when I say a matrix, what is its size going to be? Will it vary based on the data? Will it not vary based on the data? How will it work?
Rows and columns.
Yeah, how many rows, how many columns for this matrix, confusion matrix?
2 rows, 2 columns.
Is it always fixed?
It depends on number of classes.
Okay. So if I have, let's say, if I go for 3 classes, how many will it become?
Then it would be 3 by 3 matrix.
It would be a 3 by 3 matrix. All right, fantastic. Okay, so for those who are wondering what we are talking about, so confusion matrix is basically that matrix which gives you the number of true positives, number of false positives, number of true negatives, and number of false negatives. Okay, so that is going to be the confusion matrix. And the size of that confusion matrix for a basic logistic regression, which has only 0 and 1, is going to be 2 by 2. Okay, and that is what we are going to get here. We are going to have 14, 2, 3, 8. Now, in a standard confusion matrix, what is going to be here? 1, 0. What is this one? What is 0? Is it for actual 1, actual 0, or predicted 1, predicted 0 in the columns?
So the rows are like actuals and columns are like predicted.
Sure. Are you sure?
The horizontal, if you look at it horizontally, those are
So you are telling 14 and 2 are actual, 3 and 8 are predicted. Is that what you're trying to say?
no sir, 14 and 2, 14, 2, 3 and 8
Okay.
are actuals.
Are actuals?
Yeah,
Okay.
and
So
14,
will it be
3,
1, 0 or 0, 1?
so it will be 1, 0, 1, 0.
It will be 1, 0, 1, 0. Sure.
That is my guess, sir.
All right, fine. Okay, fair enough. So just revisit the videos again. So you have to be sure on this. It's actually going to be 0, 1, 0, 1. All right.
Okay,
So
sir.
this is sir's this thing. So you're going to have 0, 1, 0, 1. And these are going to be actual zeros and actual ones, predicted zeros and predicted ones. All right. So that is what it's going to be. So this is going to be your confusion matrix. Any questions so far?
Sir,
Anyone else?
is the order important, like 0, 1, 1, 0? If at all there are more than 2, then also is the order important?
It becomes 0, 1, 2. Yes, because based on that only you are going to take true positives, true negatives, false positives, false negatives, so on and so forth, right? So if the order changes, the values for the diagonal elements change.
Okay. So generally true positives are like 0, 0, 1, 1 or 2, 2, right?
Whenever you say true positive, so you are going to look at the positive value and it's going to be true. So whenever I'm predicting 1, is it actually 1? So that is a true positive.
Yeah.
Whenever I'm predicting 0, is it actually 0? That's a true negative.
Yeah.
So the same combinations are always true positives.
Okay.
Okay.
And this
The
can
false,
be extended to third class.
Yeah, it can be extended. For all diagonal elements, it will be true positives, true negatives. Again, it will be true positives only.
Okay.
True positive, true negative.
Got it, sir.
All right. And in logistic regression, the confusion matrix is always 2 by 2 because you will always do 1 against the rest. Fine. So it's always going to be 2 by 2. You will not get a 3 by 3 case. In general sense, let's say you are building some other model where you can handle 3 classifications. At that time, a confusion matrix can be 3 by 3. But for a logistic model, it's always going to be predicting y is equal to 1, y is equal to 0. So it's always going to be a 2 by 2 confusion matrix in a logistic regression. All right, making sense?
So can we conclude that logistic regression is applied only to two classes of?
Not necessarily. I can do placed. Let's say instead of day 0 placed, I just had placed or not placed, and then I had day 0, day 1, day 2. Then I will classify it as people who placed in day 0 and others, people who placed in day 1 and others, people who placed in day 2 and others. Right? So I'll be building 2 classes of models, whether he got placed in day 0 or whether he got placed in day 1. Based on that, I will tell the day 2 if I don't have not placed category. So I have to build so many regression models, logistic models. Making sense?
Yeah. So multiple labels, binary classes.
By multiple labels, binary classes. Yes. 1 and everything else will be 0. Correct.
Got it, sir.
Okay. Any other questions from anyone? Everyone with me so far?
Yes, sir.
Okay, right. And so this is your confusion matrix. Whatever you calculated as number of true positives, number of true negatives, number of false positives, number of false negatives. Right. Having done this, the next piece that we have to do is we have to confusion matrix. The next one is classification report. So that is where you get all of your this thing. What is that? Your accuracy, precision, recall, so on and so forth. So IN report data underscore so now you get your precision, recall, and accuracy. Since we have only discussed this with you guys, we will not focus on F1 score, macro average, weighted average, so on and so forth. So the values that we will focus on are 0.82, 0.88, 0.80, 0.73, and 0.81. All right. Okay. So now let's take accuracy for the first bit. So the accuracy is 81%. All right. And whatever we got from Excel for Sir, it was also 81.48%. So it matches. The precision that is got in the Excel is 72.7% and 80% for recall. The precision that we get here, you have to see the precision for one. We get 80 and 73%, right? So does it match? It does not. The reason for this is Python uses a more powerful optimizer behind in its behind, so it will be able to judge the values of beta naught and beta 1 to a much more better accuracy. Let's put it that way. All right. So that is also one of the parameters that you can change, and that is why there will be a slight difference. So though the accuracy is right, the confusion matrix, if you see, it was 14,238, whereas in Sir's data set it was 14,328. Making sense? So because of this variation, there will be a variation in your precision and recall. Okay. Having said this, let's now see the four values that we have. So we have a precision and recall for 0 and for 1. And this is very, very important from a business analytics perspective. Leave out the difference. From a business analytics perspective, we have to look at the precision of the model based on our business question. All right. So here we are looking at the business question or of will a guy get placed. So I'm interested in one. So my precision and recall I should focus on are 0.8 and 0.73. Whereas if I was interested in predicting whether a guy will not get placed, then my precision and recall should be 0.82 and 0.88. So the precision and recall values will vary based on your based on what your business problem is. And please revisit again once more Sir's videos where he beautifully articulates this. All right. So I'm not able to recall the exact wordings, but please revisit. He will always say what you are interested in. Based on that, you will compute your precision and recall. Since Sir's example was interested in predicting the ones, we determined the precision and recall for the ones. All right. So that was the reason that we got these. We were focusing on these two numbers. Whereas if we are interested in zeros, we would have focused on 0.82 and 0.88. As an example of where this could mean something, let's say in a medical field, you are administering a new drug and you are seeing whether a side effect happened or not. Then you are interested in only those people where it did not happen, right? So you are interested in the zeros. So in that case, the values would be for this. Making sense? This is very, very important because without the business context, you will not be able to calculate your precision and recall without knowing for what business context. You will calculate it, but you will not be able to present it, project it to for what purpose. Okay. Anything else? Any questions so far? Okay, and Deval, yeah, right. So this is the precision recall curve. I didn't know whether sir had discussed this with you guys. So
Sir, I just saw that.
yeah. So this is the precision recall curve for this data. Okay. Any questions? So in fact, this was the demo that I wanted to do with all of you. Right. So that is the logistic regression demonstration of how to do it in Python. I believe you guys would be far more experts in this, those who have taken ML course. But just a recap, if you have not. If you have taken, just recap, and if you have not, I hope it was helpful. Okay, so we are open to any questions that you may have.
Hi, sir. My question is a very basic question. The beta knots and the beta ones taken by sir in the model, was it from the multiple linear regression, or had it been calculated differently? Because I thought I skipped that part.
What do you mean by multiple linear regression?
Sir, the coefficients, the beta knots and beta ones that were taken, were it the same that were taken for multiple linear regression, or was it calculated differently?
I am not able to follow your question. We are talking about logistic regression. We are talking about multiple regression, two different models. So
Yes.
what do you mean by were it calculated?
So can you show sir screen? I think I might.
1 second. Yeah, so this is sir's screen, sir's logic model.
So the B0, B1.
Yeah, fine. I get that you're asking me this. I am not able to relate it with how you are getting confused with multiple linear regression. So that's a different thing altogether.
Sir, can I
Please
jump in? So professor told that these values B0, B1, B2, B3, B4 are obtained from multiple linear regression. So we have started with these numbers, right? And we have found out that sum of log likelihood is minus 7.87 something. So we have to maximize this by changing B0, B1, B2, B3, B4 values.
Correct. So sir optimized this. So he fit an optimization model, I believe. He went into data solver and then fitted.
And that is done using MLR, right?
No. The solver does solving of an optimization model, right? So that is different.
Okay, we were not shown that. So
that is not in scope for you, so we have not shown it to you. What we do is okay. So we have sir would have put accuracy, I believe, right? Sir would have taken accuracy as your sum of log likelihood. Yeah, this would have been your objective function. Okay, students they are familiar with optimization, correct? I believe Shreya has left. Okay, so you guys familiar with optimization?
Yes, Valana.
Yeah. Okay, they are also familiar. Thank you, Shreya. So the objective is to change this cutoff, to minimize this cutoff, such that these values have to be determined. And so objective is this, and these are your decision variables, and you just solve the model, and you get your beta knots. To start off with, you have to give some random betas, and those random betas might have been given by sir. Making sense?
Yes, sir. Got it.
Okay.
And you could have very well. So you're talking about the solver, right?
Solver, yes.
So
no, they are asking me. The question that they are asking is, were these betas got from a previous multiple linear regression model? That was my understanding. And I said, no, they are actually fit for this data set using solver.
Okay. So general for a solver, you can enter some random values in those cells which you consider to be the decision variables, or you can leave it blank. It will automatically solve and give you the answer.
It's basically like giving zeros if you leave it blank. I don't remember the videos exactly. Has Sir pre-input some values? Shivansar Swami, do you remember?
No, Malaran, sir had not shown this demo explicitly. He had just solved it here, and he had given the intuition behind solving logistic regression using Excel.
All right, fine. Okay. Okay, so I hope that answered your question, whoever asked us.
Yes, sir. Got it. Yeah.
Got it? Yeah. Anything else from anyone else?
So I have a question regarding understanding or interpretation of odds.
Okay.
So when sir says, like, when we say 1 unit increase in MBA CGPA, this will lead to increase in odds of student getting placed by 26.31. So is it like, I'm confused, like it's not probability, it's not
probability.
percentage.
It's not
So how do I
it's the
take
ratio.
it? Is it
It's
good?
the ratio.
Okay.
Probability of Y happening to probability of Y not happening is going to increase by 26%. Right?
Okay.
That is the odds. The odds of Y, probability of Y happening to probability of, I don't know how else to put it, P of Y equal to 1 divided by P of Y equal to 0 is going to become 20, it's going to increase by 26%.
Exactly like him.
Okay.
Okay, sir. So higher the better. How do I like interpret it? Generally, percentage or probability I can understand.
Higher
right?
better, no? Higher the better.
Okay,
Because
sir.
the higher your chance, because P of Y by P of Y is equal to 1, by P of Y is equal to, okay, that also depends on the problem. Very good point. So P of Y equal to 1 divided by P of Y equal to 0. If it increases, then basically it means your probability of Y equal to 1 is going to increase. Correct? Your numerator is going to increase.
Yes, sir.
By something. So if your problem is predicting Y is equal to 1, then it is good for you. If it is not, it is bad for you.
Okay. So in
Adding
case
to-
of 3, sir,
Yeah.
3 classes.
Once again, yes, Swami, go ahead.
So I just wanted to add a few more things to what Malolan said. For example, let us take this odds ratio. You have probability of Y is equal to 1 divided by Y is equal to 0. So when is this odds ratio going to go up? When your probability of Y is equal to 1 is increasing, this odds will increase. Also, if the
And
probability
simultaneously,
of
just to add to Swami, simultaneously, Y is equal to 0 will decrease.
yeah, so when
That is
Y
also
is equal to
important.
0 is also decreasing, your odds is going to increase.
Okay. It is kind of relative comparison also. Then
What do you mean by relative?
one increases, other decreases.
But that is by default, no? Because probability can only be 1. So if P of Y plus P of Y is P of probability of Y is equal to 1 plus probability of Y is equal to 0 is equal to 1. So obviously they are related. If one increases, the other has to drop.
Okay, sir.
Right? So that is the entire phenomenon behind this. That is why you have that S curve. This goes up, that comes to 0. Okay. Anything else?
Sir, one question. What would be the meaning of probability of correct prediction? What is the Meaning of
Ah.
that, and how do you write it in probability sense? Is it conditional probability or?
No, it's not conditional probability. So probability of correct predictions is true positives and true negatives. Okay. So we are always predicting for probability of y is equal to 1. All right. So let me take the Excel and explain. So it will become much more clear then. Right. I hope you are able to see. So
Yes,
let's
sir.
take this one. Okay. So this is going to be your probability of correct prediction. Yeah. So this is going to be your logistic model is going to be based on this. Correct? It's going to be based on this probability. So when your model is 1, if you are getting 0.9, you are predicting 0.9 because you are predicting for probability of y is equal to 1. Whereas when you are getting 0, the probability of correct prediction is 1 minus this value because this is the probability of getting 1. Then the probability of getting 0 is what? 1 minus that value. Making sense? So the
Yes, sir.
probability of correct predictions is whenever your classification was 1 and the actual was also 1, what was the probability of that happening? Making sense? 1 or 0. So when your classification and actual are having the same value, true positive or true negative, what was the probability of that event happening? That is your probability of correct estimation. So in the case of probability of y is, since you are predicting probability of y is equal to 1, it will be the same value of the odds ratio as correct thing. And for true negatives, it will be 1 minus that value. Making sense?
Yes, sir. Got it.
Got it? Yeah. So that is the difference. Now that is what probability of correct predictions means. Anything else? Any other questions? Okay. So if there are no questions, I'm done. Srivastava, Swami, do you have anything?
Just one small thing. So we really hope that you saw the logistic regression tutorial before this live session. It would have been much more interesting. So I sincerely request you to watch the logistic regression tutorial video because we have used a very interesting data set. And I'm sure after watching that video, you will have a lot more questions. So whatever doubts you have, please feel free to post on the discourse forum. We'll be there to guide you.
Yeah.
So just a query. May I ask?
Yeah, go ahead, please. Yeah.
Sir, on plotting the linear regression, simple SLR model. So when we plot the graph for that data, we get different B naught and beta naught and beta 1. And on
Can you please repeat? I didn't get the entire thing. Yeah.
okay, so the SLR model of the raw data gives different beta naught and beta 1 value, and the graph which we plot of the raw data, that gives different beta naught and beta 1.
Follow. Srivastava, are you able to follow?
You're saying
Okay, let
on
me.
Excel, the value which you get is different, and when you solve it using data analysis toolpack, you're getting a different solution. Is that what you're suggesting?
Yes, sir.
Did you check whether you're using the same data?
Yes, sir. The point being, the range is correct, but the actual value is not same. I mean to say that in the ANOVA table, below the ANOVA table, there is given the maximum and minimum value to which the beta naught and beta 1 value shall be there. I mean the range,
So yeah, the significance level, right?
yes.
So within that confidence, that variable is significant would be given in the data analysis final result. So is this with respect to the second assignment?
Yes, sir.
I think Gemini was looking at it. Maybe can you tag Gemini on Discourse and post this question there?
Okay.
I don't know. I believe her question is this: if you solve it in Excel, you are getting a different beta naught and beta 1. If you are solving it in Python, let's say you are getting
No,
a
no, no,
different
no,
beta.
no. I am not
Is that what
solving
you're
in
saying?
Python. No, the
Okay.
data analysis pack, the tool pack.
Or tool back in Excel, when you use that, you are getting a different answer for
Beta
when
naught
you
and
use
beta
the,
1.
when you use the tool back, you're getting a different answer. And when you solve it manually, you're getting a different answer. Is that what you're telling?
Yes, sir.
Then I do not
We
know.
have to check again mostly because
It should not vary within the same tool.
So
It should
the
not vary.
manual calculation which I calculate is in the range.
Correct, ma. It will fall in the range because it's significant. That is the significance range.
But it
The
is not the
range-
same one.
It is. It should be. So we'll have to see why it is not.
So
Don't
sir,
give out
shall
the
I
answer.
post in the
Don't give
discourse
out the
with the
answers. Don't give out the answers in discourse.
Okay.
Write it as a mail maybe. Tag Gemini and write it as a mail. We might be able to help you out.
Gemini, sir, and what?
Gemini, you can put it as @Gemini. He's also one of the course instructors. Second name in our thing about the course page.
Okay.
Right? So that will be so. It would be better if you tag him since he creates the questions. He'll know the ins and outs of it. So please tag him.
Mm-hmm.
Right. Yeah, one thing that I forgot. In next week's live session, we'll be having Professor Marathe with us. So Rahul Marathe sir will be with us. So any questions that you have in the first 8 weeks of content or 7 weeks of content, you can discuss with sir as well. So all of us along with sir will be here, and that is going to be the purpose of next week's live discussion. We'll also send out an announcement about this for everyone's benefit.
Sir, I have one last question. Probably it's regarding the assignment 1 questions. Actually, sir, we got the answers. I have just one confusion. If we are not able to clear with the which particular model this all data depicts, you may be discussing. Sir, I may not be part of those discussions. So sorry about that. So if those data I'm not able to predict, and if I understood that okay, this may be following geometric prediction. And based on that, if I reject the null hypothesis, will that not be a correct answer? If I'm not able to understand the flow based on the data, whatever we have, I'm just trying to understand that. If I can hypothetically choose a particular distribution, maybe a geometrical. So in this case, and then I calculate the chi-square value, and then I see if it is not following, I can reject it. Will that not be a kind of assumptions for us if I'm not able to relate at all with the diagram?
That is the whole point of doing a chi-square test. No? So if it is not matching, it will get rejected. So if you are not able to follow the diagram, fit every distribution, check the chi-square test goodness or fit test, and conclude accept or reject another.
Actually, sir, see, I may be wrong, but my in the questions, my geometric distribution is actually accepted. I got the value which actually accept the null hypothesis, so I considered that. But probably you said uniform distribution is this is the uniform distribution and reject the null hypothesis. So I'm just confused there. If I consider geometric hypothesis and it accepts the null.
You have considered geometric distribution.
Yes.
And it has accepted the null. The data was from uniform or normal?
Manolan, the data was from a uniform distribution.
Okay.
And so I wanted to add a few points here. So we have few theoretical distributions like Poisson, uniform, geometric, and so on. So our mentality is that whatever data we have, we think that it might come from a particular distribution. It might be either from Poisson or uniform or geometric and so on.
Right.
There are a class of data which does not fit into any of these distributions. That is also possible. So
Right.
it could be an empirical distribution which may not fit into all these theoretical distributions as well. So
Right.
there is very high chance that your assumption of this data set, the parent distribution of the data set that you are working on, may not fit into any of those theoretical distributions. So just be aware of that. That is what I wanted to add here.
So actually, sir, I'm just confused in terms of how we can assume that this particular will follow that, because geometric actually accepts the null hypothesis in my case. I may be doing wrong. So do we have any like that QQ plot and PP plot probably not able to distinguish those data? So just trying to understand if we have any other way to, in terms of numerical calculations, we can understand which it go before going into the chi-square.
So that's why. So I get your point. So this is not an easy task. So that's why we gave you enough hints. We gave you a list of 4 distributions. We said whether it could be uniform or binomial and so on. So we did not give you a lot of options. So we gave you very limited options, and we also gave you enough hints like minimum value plus maximum value by 2 and so on. So these are the hints which would have forced you to consider uniform. So that was the idea behind this exercise. But you are thinking in the right direction. So there could be a lot of factors. You could also, whatever you say may also be true. Well, null geometric distribution.
But I lost the marks, sir. Actually, I got so can be geometric can be a correct answer.
No, it cannot be, because see, we have given you the descriptive statistics, right? So that was the starting point. So the graphs, the histogram, the descriptive statistics, I don't think those will
match geometry.
Yes, match.
Okay.
Usually the challenge with the chi-squared goodness of fit test is when you have very limited data. For example, that was one of the reasons why we gave you a small data set. When you have very limited data, only depending on that will lead to a wrong answer. You should also depend on some amount of descriptives and the graphs. So when you have a small amount of data set, you can't conclude explicitly with chi-squared alone. So if you are dependent on that for answering everything else, you'll get it wrong. You should see the entire spectrum and do it. So yeah.
So
the other to Swami. Yeah.
So the other idea behind giving this data set is, tomorrow when someone gives you a data set, say 8 points or 10 points, and asks you to do some predictions or find the distribution and so on. So tomorrow you have to tell them, well, 8 points is not enough to come to a conclusion. Give me more data. So that should be your approach. So that was the idea behind giving you such a horrible data set. And sorry for that.
Okay. No problem, sir.
But yeah, you should not depend explicitly on data. Look, the tests, the hypothesis tests are good. They are extremely reliable when you have sufficient data. You can't rely on them explicitly. Only rely on them when you have small data sets. You should have some amount of other justifications to go along with it. And yeah, so that is why, like Swami said, he gave you a very, very difficult data set. I'll not use the word this thing, but yeah. Please, you can leave the live session. No problems.
Yeah, but thank you so much, sir. Yeah, thanks for your response.
Sorry, I was talking to a chat message that I saw, not to you, Nishant. This was for a chat message.
Okay.
Yeah.
No, yeah, but thank you so much for your response, sir.
Sir, we were given Python codes to determine 3 kinds of distributions. Is it possible to get Python codes for geometric and binomial as well?
You will have to develop it on your own. Like I said, go to the package that was used, see the documentation, it has everything, what parameters you need and where you have to fit it.
Okay,
so if you do that, you'll be able to do it for any.
But like each kind of distribution had a specific method to find the expected frequencies.
Expected frequencies, yeah, because the formulas changed. Huh? For uniform it is different, for Poisson it is different formula. Probability of that event happening in Poisson is different, right? In uniform it is different. So accordingly, you'll have to calculate the frequencies. So if you are doing it for, let's say, some other geometric distribution, then you have to put the PMF or PDF for that distribution, get the information.
Okay, sir.
So that is why we didn't go into all the distributions primarily because of this. You could keep on generating more and more distributions as you dig log normal, something of that sort, right? So it will keep on going. So that is why we have stick to only 3 for the entirety of this course.
Sir, I
Yes.
posted this query on Discourse as well, that for uniform distribution, we actually use the expected value instead of expected frequencies.
Right. So you had posted it. I was going to answer this tonight, but anyhow, since you're here, I'll give it to you. In uniform distribution, the chance of any event happening is the same.
Yes,
All right. Right. Okay.
Yes.
So let's say you are given 100 numbers between 1 to 5. And if everything has an equal chance, then the number of ones that you will see is 25. The number of twos that you will see is 25, which is nothing but the average, right?
Yes.
So that is why the expected frequency is the mean.
But sir, that would be the expected value of the random variable x, which is uniformly distributed.
Correct.
But let's say, as far as that chi-square function is concerned, it takes the frequencies.
Observed frequency minus that is what I'm trying to say now. If I've given you 100 values between 1 to 5, then 1 should happen 25 times if it's a uniform distribution. The expectation is 25. 100 by 5 is what? 25, right?
Yes,
So
but
25 ones, 25 twos, 25 threes, 25 fours. So if it's if this data is coming from a uniform distribution, the expected frequency for each element is that number of this thing by n, which is the average.
And then the observed one should be the frequencies of how many times we actually observed one.
Actually in the sample, yes.
But actually, in the lectures, that there seem to be something else, but right? So the first is actually the actual observed values and not the frequencies.
1 second. Let me open your discourse. I believe you have put this thing also, right?
A screenshot, yes, sir.
You have put a screenshot. Let me just open it up. Okay. No, the DF, that is 18, 19, 20 you're talking about, those numbers.
No, sir.
The next one, 51.0097.
That is actual observation and not the frequency of the observation.
It's actual observation.
Yes, sir.
I will have to check again. Then I have to check the code. I don't believe so.
Sir, actually, yes, sir.
Okay, let me check the code. Or else I believe you are missing something here. Let me check the code. That should be a continuity. 54.92 is the expected value. This should be the observed value, or is it something else? You have to check the flow of the code. I'll check the flow of the code and I'll get back.
Yes,
okay.
Sir.
My thought from an initial reading of the question, I thought you were asking about how is it 54.92. That is the mean value.
So for in this case, we must have to bin all those values and find what the expected frequency should be from that bin.
No, let's say you're having, like I said, I do not see the data set for me to read it out immediately. But let's say you are given a uniform distribution between 1 to 5. Okay. So yes, 1, and you are given 100 values. And 1, how many times it has happened? 2, how many times it has happened? 3, how many times it has happened? 4, how many times it has happened? 5, how many times it has happened? Is your observed frequency.
Yes, sir.
Your expected frequency, since I have given 100, 1 to 5, each would be 25.
Yes, sir.
So the bin is basically 1, 2, 3, 4, 5.
Exactly, sir.
And and
yes.
your observed frequency is going to be from your sample. Expected frequency is going to be 25, 25, 25, 25. Chi-square is going to be observed minus expected the whole square by expected summation over n, summation over 1 to 5. Right?
Yes, sir. But what actually happened as per me in the code is that we have listed 1, 2, 3, 4. Let's say 1 came 30 times, so we have listed 1 30 times. And in the expected side, we have taken the 1 plus 5 divided by 2, which is 3.
Okay. I believe that would have been a step that he consolidated. Let me check the code. Like yes, I said, we have consolidated and we have got the values. I believe you are missing a connecting point. Let me just see the connecting point. Yeah.
Yes, sir. Yes. Thank you, sir.
All right. So,
sir, another point, sir. Actually, when I came across some online stuff, they actually mentioned that the chi-square, the bin value should be at least 5. Sorry, the expected frequency should be at least 5. Theoretical.
Theoretical.
Yes.
Okay, there is a thing over here. We didn't focus much on it in the course. The theoretical expected frequency, it would not have been said at least 5. It would have been corresponded to your x. For example, let's take your measuring number of defects, and you are measuring 4 defects, but the theoretical frequency is coming as 3. You can't find 4 defects with 3. So you will say 3 or more, 3 plus more, and add it to that, and you will do.
Yes.
Yeah, so that is how it works. If it 5 is not a fixed number, and there is no fixed number, usually they ensure that the theoretical frequency is greater than whatever you are trying to measure, because you cannot have a theoretical frequency lesser than whatever you are trying to measure. That is just a practice. But your entire let's say logic will work even if this is not the case. Making sense? So it will work without that. But general rule of thumb is that observed expected frequency be greater than what. Let's say you are measuring number of defects in an item, and for 5 defects, the observed frequency expected frequency is coming 4. You can't have an item. You can't look for 5 defects and have an expected frequency of 4. You will have to have more than 5 or more. So you will say 4 or more and add that value to the previous row and pull it out. So cumulatively, you will see you will reduce the number of case. I believe that is what the book says. Okay.
Yes, sir. Thank you, sir.
All right. Anything else? Right. If you do not have anything else, not an issue. We are just hanging around for 1 or 2 more minutes. Then we will post live sessions. If you have any questions, please ask us, or we will post live sessions. Okay. Our team, I think we can close here. Yeah, next week we'll meet you guys. Yeah, thank you, Swami. Thank you, Shirit sir.
Thank you, everyone.